Hi guys, and welcome to my channel. Today we'll talk about SSD SATA, how to make it work, what you need to know, everything you need to understand about this storage device. Let's get started. How to make an SSD SATA work. First off, let me explain what SSD SATA really is. It stands for Solid State Drive with Serial ATA Interface. As you probably guessed, it's a storage device just like a regular hard drive, but uses the same familiar SATA interface that most of us are used to. This allows us to connect it to our motherboards without any additional adapters or controllers, and it works right away. If you have a newer machine, it will also support SATA Express or M2 drives, which offer even better performance, but those are more expensive, and we're focusing on SATA here. Now let's see what you need to set up the SSD SATA and start using it. We'll split it into hardware requirements, software requirements, physical installation, software setup, optimization tips, and finally troubleshooting and maintenance. Hardware requirements. For the hardware part, we need the obvious, an SSD SATA itself. They come in 2.5-inch form factor, which is what fits most laptops and desktops. If you want to install it in a laptop, check what type of connection your machine uses. Some older ones might have the smaller 1.8-inch drives, but they're slower and harder to find these days. So 2.5-inch should be fine, just make sure to keep the mounting screws that hold it in place. Next, we need an available SATA port on your motherboard. Most of them come with at least 4, so chances are you have one free. You can check your motherboard's manual online to see where it's located, or use the manufacturer's website in their tools to see a diagram of your specific model. Also, you'll probably need a SATA data cable unless it's already connected to your SSD. These cables usually aren't included with the SSD. Sometimes they do, but often you'll need to get one separately. They're cheap, and you can get them anywhere. Don't worry about the length, just make sure both ends are SATA connectors. Another thing you need to take care of is the SATA power connector. It's the bigger one that goes into the SSD, and it provides power from your PSU, the power supply unit inside your machine. All modern PSUs have these connectors, and they usually come with a few. However, if you have an older or cheaper power supply, it might not have enough connectors, or might not have them at all. In that case, you'll need to upgrade to a newer model or get a SATA power adapter, which connects to your PSU using the Molex or other proprietary connectors and splits into several SATA connectors that go to your SSD and other devices. The next hardware requirement depends on whether you're installing the SSD in a desktop or laptop computer. Desktops need an available drive bay where you can put the SSD. Most ATX cases come with at least two 2.5-inch bays, where you can mount it using the screws. Some might not have them, and then you'll need to buy a separate caddy tray where you can put the SSD and connect it later using the SATA cables. Laptops don't have bays, but instead slots where you can replace the existing drive or use a secondary bay if you have one. Again, check the manufacturer's specs to see what size and type of connection your laptop uses. Alright, now we covered all the hardware requirements, and all we need is an operating system that supports SSDs, which is basically any modern OS out there. Doesn't matter if it's Windows, Mac OS, or Linux. They all work just fine with SSDs. Now you can download the necessary drivers and software from your SSD manufacturer's website. But often it isn't strictly necessary because your OS should have the basic drivers to run the SSD out of the box. However, some manufacturers provide additional features such as monitoring utilities or firmware updates which can improve your SSD's lifespan and performance. So it's up to you whether you want to use them or not. Next step is the actual installation. For now, let me just say, turn off your computer and unplug it before touching anything inside. Then open up your computer case or the access panel on your laptop and get ready to mount your SSD. For desktops, put it in the 2.5-inch drive bay securely using the mounting screws. It should fit right in with no problem. If your bay doesn't have a removable faceplate, you might need an adapter to secure the SSD in place. You can get these with the SSD caddies if you bought one. Otherwise, ask someone who built your PC or check the manufacturer's website. Once the SSD is mounted, connect the SATA data cable to the motherboard and the SSD. Then connect the SATA power cable to your SSD and make sure both connections are secure. If you installed it in a laptop, you should be good to go once you close the panel. But if you're doing this in a desktop PC, you'll need to reattach the faceplate and screw it back in place. Then reconnect the power cord and turn on your PC. And now comes the software setup. Once your PC boots up, you should see the SSD in Disk Management or Disk Utility. Depending on your OS, you can open these tools by searching for them in the Start menu. In Windows, it's Disk mgmt.msc, and in Mac OS, it's Disk Utility. In Linux, you can use fdisk or gparted. Now, the first time you run these tools, you should see a pop-up asking you to initialize the disk. That means preparing it for use by creating a basic structure. Click Yes and wait for it to finish. If it says the disk is already initialized, you can skip this step. You'll need to partition and format the drive. The easiest way is to let the OS handle this automatically. Just select the SSD and click the Options button. Choose Simple Volume or GID Partition Table and click Next. It will create a single partition that takes up the entire drive and formats it using the file system your OS uses by default. NTFS for Windows, APFS or HFS Plus for Mac OS, and IXT for Linux. Unless you know what you're doing, you don't need to change any of these settings. When everything's okay, click Finish and wait for the formatting to complete. Now your SSD should appear in My Computer or this PC in Windows, and in Finder in Mac OS. In Linux, it should show up in Files or Nautilus, whatever file manager you're using. If it doesn't have a label, you can rename it using Disk Management or Disk Utility. That's basically it. You can start using it right away. But before we wrap up, let me share some tips on how to optimize your SSD SATA performance. First, make sure to enable AHCI mode in the BIOS instead of IDE compatibility mode. IDE was around long before. SATA and some older systems still have this option in the BIOS, so double check and make sure you're using SATA mode. To change this setting, restart your PC and enter the BIOS by pressing the hotkey shown on the screen. Usually it's Del or F2. Look for SATA configuration or SATA mode and change it to a HCI. If you're unsure, Google your motherboard model and look for instructions. Next, check for firmware updates on your SSD manufacturer's website and update it if there are any. This can improve stability and performance, especially if you bought your SSD a while ago. Third, make sure trim is enabled. This feature is automatic in all modern OSs, but it's good to check just in case. You can use the manufacturer's SSD management software to check this, or you can use third-party tools like SSD Messenger for Windows or SmartMan tools for Linux. Lastly, disable defragmentation. SSDs don't need this feature because they don't have moving parts. Just disable it to avoid unnecessary wear on your SSD. In Windows, open Properties and uncheck the Optimize this drive for checkbox. In Mac OS, open Disk Utility and select the SSD. Then click the Erase tab and enable the Options button. Uncheck the defragment and click Done. And in Linux, use the defrag command and the A option to disable it. Now, a final tip that's optional but recommended is over-provisioning. This means leaving some space on your SSD unallocated. It's usually between 5 and 15% of the total capacity, and it helps your SSD manage its internal resources more efficiently. You can check your SSD's spec sheet to see if it recommends over-provisioning, and if so, how much. Unfortunately, there's no easy way to do this. You can use some registry tweaks in Windows or third-party tools like SSD Over-Provisioner, but I wouldn't bother if it's not strictly necessary. And now I promised you some troubleshooting tips. First, if your SSD isn't detected at all, check the SATA connections. Make sure they're secure and try a different SATA port. Then verify your BIOS detects the drive by looking for it in the Hardware or Mainboard section. And if you can't find it, try updating your BIOS or Googling your motherboard and BIOS to see if others had similar problems. If it's an older system, it might not support SSDs properly and you'll need to upgrade to a newer board. Second, if your SSD is detected but it's slow, make sure it's connected to a SATA 3 or 6 gigabit per second port. Use your motherboard's manual or diagram to verify this. If it's not the problem, check for driver updates on your manufacturer's website or through Windows Update. And lastly, verify that trim is working correctly. You can use the same tools I mentioned earlier to check this. And now some maintenance tips. First, keep at least 10 to 20% of your SSD free to maintain optimal performance. Filling it up completely can reduce its lifespan and cause issues. Second, back up your data regularly because SSDs can fail suddenly and without warning. And third, Monitor your SSD's health using tools like Crystal Disk Info in Windows, SmartCoal in Linux, or Drivids in Mac OS.
These tools provide valuable insights into your SSD's condition and help you detect potential problems early on.
So that's it. Hopefully this guide was helpful and you learned something new today. Thank you very much for watching, and until next time, happy computing.